This particular example uses the t-table and looks to try and find a level of confidence based on certain information. So consider a manager of a shopping mall wants to estimate the average amount of money customers spend when shopping there. From a sample of 20 customers, the mean and standard deviation from this sample finds that the amount of money spent at the mall while they were shopping there was $49.35 and 9.03. So notice the 49.35 will be the mean of X bar, and the 9.03 is the standard deviation of the sample, or little s. So based on that information, the confidence interval is calculated to be this for the mean amount of money spent. So the question is, what level of confidence was actually used to develop this confidence interval? So what we're actually doing here is using the t-table and going backwards, and so this is why we refer to it as a reverse type question. So to find the level of confidence, what we can actually do is use the sample mean that was given in the question, or alternatively, some questions you're not given the mean. So I've just put in an extra step here. Let's say we weren't told the mean. Well, we could actually find it, the sample mean, from using the upper and lower limits of the interval. And the way you would do that would be just to add the upper limit, 53.57, and to the lower limit. And if you add those two together and divide by 2, you get 49.35. So if you look in the original question, we were actually given that this is what the sample mean was. So that shouldn't come as a surprise, really, because based on the sample mean, we add the sampling error to get the upper limit, and we subtract the sampling error to get the lower limit. So the average of these two numbers will actually bring you back to the sample mean. So that's a useful trick, just bear it in mind, because in certain other questions you do have to actually use this idea of averaging the upper and lower limits to get the sample mean. So given that we've got the sample mean, the next thing we can do is find the sampling error. And we can do this again by using the upper or lower limits, and I'll use the upper limit of the confidence interval. So if you think about it, if you take the upper limit and subtract the mean, that should give you a positive value. And it should equal the sampling error, which is what we've seen when we've got a particular problem involving the shag character, which relates to when we have a sample mean when we don't know the population standard deviation and we do know S. And when we use S, we know we use T. So just notice this is the critical value for this particular type of problem. So if we take the upper limit, which was 53.57, and subtract X bar, we get positive 4.22. So notice if we had the lower limit in here, we'd actually get a negative value. And I'd rather work with positive numbers, so that's why I've chosen to use the upper limit in this case. So now that we've got this expression here for the sampling error, we can calculate the critical value by simply substituting in all the values we now know. And we know little s, we know n, that was given in the question, and we know the sampling error is 4.22. So if you rearrange this equation, following these steps, calculate this out, you'll get the critical value is 2.09. So we're almost there. We now know the critical value of the particular confidence interval we're looking for. And here's the level of confidence in here. So remember, with the confidence interval, we have an upper and lower tail of alpha on 2. And in the particular question we're being given, the sample size is 20. Because it's a single mean type question, we know the degrees of freedom is 19. So if you take out a t-table and try and find 2.09 in that table by going down to degrees of freedom of 19, go down to degrees of freedom of 19, and then across the row, I won't do it here, but if you're following this on a table, you can go across and find 1.729, and the next number is 2.093. And at the top of the table, you'll see that that matches the upper tail areas of 0.05 and 0.025. So just recall that the upper tail area will be alpha on 2 for this question because we're talking about a confidence interval. So if that's the case, we should be able to double these values of alpha that are at the top of the table and get 10% and 5%. So now that we know the value of alpha being 10 and 5, it should be a simple case that the level of confidence is just 100% minus these tail areas. So 100 minus 10% will give us 90%, and 100 minus 5% will give us 95%. So there you have it. This critical value of 2.09 lies somewhere between these two values of 1.729 and 2.093, but that corresponds to these values of alpha of 10 and 5, and so we now know that the level of confidence used to generate that earlier confidence interval must have been somewhere between 90% and 95%.